Hi, for this video what we are going to do is we are going to solve a radical equation, and for this one it results in a quadratic equation that you would have to solve. So in order to do this, remember that our goal for a radical equation is to first get the radical alone on one side. So since we have a positive 3, we're adding 3 to this side, we would want to subtract the 3 from the other side. If you don't want to write it like that because that's confusing, you could just say I'm going to take this negative 3 or this 3 to the other side, and when it goes to the other side it becomes negative. It really doesn't matter how you do it. Just either way, you want to make sure that when you make the positive 3 move to the other side, it becomes a negative 3. So once you have the radical isolated, remember that what we do is we square both sides. Or if it was the cube root, you would cube both sides. Fourth root, you would take it to the fourth power, etc. So for this one, we're going to square both sides. Don't forget on this part right here, x minus 3 squared really means x minus 3 times x minus 3. So you have to make sure that you FOIL out. So you do have a middle term because we have a negative 3x and a negative 3x that we would have to add together for the middle term. So with this, if you square a square root, remember that those cancel each other out. They're the opposites of each other, so we just end up with what's inside. On this side, we square the first term because x times x gives me x squared. We would then have a negative 3x from this outside one and negative 3x from the inside one, so we have a negative 6x if we add those together. And then we square the last term, which gives us positive 9. So for this one, like I said, this one is going to result in an x squared or a quadratic equation. So because this is quadratic, we want to make sure that this term is positive. We want to make sure that our quadratic or x squared term is positive. So what we're going to do is we're going to subtract the 3x and subtract the 1 and bring both of those to the other side. That way we have 0 on this side. It doesn't matter which side the 0 is on. You just have to make sure that you have it. So we end up with x squared minus 9x. And then 9 minus 1, remember that we sum them if they're the same sign. Same as sum. So 6 plus 3 is 9. They're both negative, so we would keep the negative. 9 minus 1 gives us positive 8. And then what we are going to do is we're going to factor this side if it's factorable. If it's not, you would have to use the quadratic formula, and then it becomes much more complex. But this one is factorable. Remember, what we're looking for is two numbers that multiply together to give us the last number, which is 8, that add up to be the middle number, which is negative 9. So that's technically what we're doing here. So with this one, because I need a negative here and a positive here, that tells me that both of these signs must be negative. And so the values that would work would be 8 and 1. So this factors into x minus 8, x minus 1. And then remember that we take and put each of those equal to 0. So x is either 8 or x equals 1. And the way that I got this was I just took this x minus 8 and set it equal to 0. The opposite of subtracting 8 is adding 8, so 0 plus 8 is positive 8. So that's where that came from. Make sure that you check your work. If you don't check your work on this, you're most likely going to end up with the wrong answer because most likely only one of these solutions is going to work. It is possible that neither one of them will work. So you always want to check your solutions with radical equations because of the extraneous solutions. So when we check this, if we plug in the first value, so let's plug in 8 into our original equation, we would have 3 plus the square root of 3 times 8 plus 1. And we're going to see, does that equal 8? So we're going to ask ourselves, does this equal 8? So if we simplify, this gives us 24 plus 1, which is 25. And the square root of 25 is 5. And 3 plus 5 is indeed 8, so we know that that works. So we know that x equals 8 is a valid solution. We have to check the other solution to see if it works or whether it does not. So with this one, we have 3 plus 3 times 1 plus 1. And we're seeing, does that equal 1? So with this one, what happens here is we have 3 plus This part right here, 3 plus 1 gives me 4. And we can see that 3 plus 2 does not equal 1. 3 plus 2 is 5. So this is not a true statement. So this is what is known as an extraneous solution. So make sure that no matter what type of radical equation that you have, especially if it's a degree 2, that you always check to see if your solutions work. As always, thanks for watching.